So in looking at the pinouts of the Z88 processor and the PIO, you'll notice that the +5 for the processor is on pin 11 and ground for the PIO is on pin 11. And then ground's on 29 here and +5 is on 26. And when I had these parts in the wrong sockets, that basically means I was putting +5 into the ground pin on the PIO, and where ground is on 29, it's hard to say. It's possible I've damaged one or the other or both parts because of that. Like I say, it's hard to say. So I went over to my parts box and I pulled out a couple of Z80A CPUs. This is a Z80 CPU. The A's are, I think, a 2 megahertz. These are 4 megahertz parts. And a couple of Z80A PIOs, and then a couple more just Z80 PIOs, not the A. Date code is 77. And date code of, that's hard to read, 4th week of 80, I believe. And the ceramic, so kind of cool. But what I'm going to do, I think at this point, is I'm going to replace the processor first. And see if that gets us any closer to operational. Pull out one of these A CPUs. Yeah, it really sucks I got those in backwards. Oops. 600 mils on this side. I can see that I've got a pin that is not straight. Power supply, let me get it up and running. We are to monitor restart. We are going to read, I don't think the switch actually matters, but it's going to reset to the monitor. Let me turn on the power. Reset to the monitor and nothing. I don't see the LEDs waking up. Let's make sure we have power where we expect to see power. So we believe pin 11 should have +5, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11. And we see 4.89 there, which is good enough. Turn the power off. And we will swap out the PIO. Wish I could find my good chip puller. You got to be careful using screwdrivers because you could get underneath into the socket and scratch, and we don't want that. So let me grab one of these PIOs. Leads look nice and new on that. Reset, and obviously because the LEDs aren't coming up, there's something else not working, which really isn't much of a surprise, honestly. So what to do at this point? Next thing I would typically do at this point, and I think I will go ahead and do this, is I will remove the ROM and the RAM, the PIO and the CTC, anything that looks at the data bus directly, perhaps a buffer or two, and then I'm going to solder a header in here and ground all of the data pins, data 0 to data 7, get jumper to ground, and that creates a no-op. And so every time the Z80 does a fetch, it should read in a no-op, and so it should just go address 0, 1, 2, 3 all the way to 65,535 or FFFF and then roll over to 0. And what that allows us to do is get a logic probe on A0 And then on A1 we should see, you know, half the frequency A0, then on A2 half the frequency of A1, because really A0 to A15 just become a divide by 2 chain as the address counts up. And that'll at least give us an indication that the Z80 is trying to run. If we don't see activity in all the address lines, then we know the Z80 isn't trying to run. So that's where I think I'm going to end up going next. Yeah, I can't think of anything else to try at this point beyond that. So let me, power is off. Pull out parts here I'm not going to need. So because I'm going to be grounding data 0 to data 7, I don't want anything in circuit that could drive those and try to drive them high, because I could damage a part trying to drive it high when it's just a direct short to ground. Wish I could find my good chip puller for the larger packages. It's just not where it's supposed to be. Of course, nothing's ever where it's supposed to be in the lab here. That's just the reality of so damn many active projects. You know, the Tandy 4 project is ongoing. Tandy 4P, actually, it's sitting behind me here. I've got another video to shoot on it. So it gets the RAM out of the way. Let's see if we can get the ROM gently up out of the way, like so. I don't think we need the CTC in. I'm also looking to see if there's any bend over pins. We shouldn't need the PIO. The 40 pin package is going to be a bit much for this style of puller. And there's going to be potentially a 244. I'm going to have to look in the manual. So let's find the schematic. I've pre-looked at the schematic. So we've pulled out the bottom bank of RAM chips here. We've pulled out the ROM. We've pulled out the PIO and the CTC. But there's also U40, need the other glasses. U48 gates the RAM back onto the data bus. And for the ROMs, it's just, so all that needs to come out at this point is U48. Wow, and it's all the way down here. That's surprising. That's really surprising to me. It's that far away from the processor and the RAM. So did I read that correctly? 1/8 of a 244 at U48 is taking care. We've got data bus. Really, the data bus in circuit here comes through here to PROM 2, PROM 1, and the Z-Bug monitor. And then it gets tapped off. There's D0, D1, D2, D3, etc. from that U48. I'm just surprised the location on the board. That really should isolate everything. If I power up now, I would expect there to be all ones on the bus, and I don't really know how the machine would act. I don't know what opcode that is or isn't. Well, let's go ahead and take a peek. just see what it does. Power on. We're drawing 270 milliamps at 5 volts. That old realistic logic probe is floating around here. I've got I think a BK Precision that's a lot nicer. Ooh, what was that noise? 280 milliamps. So A11, 12, 13, 14, 15. It looks like that's being, it looks to me like it's actually seeing no ops. So let's get to A11 here. And notice that the low LED seems to be on, but the pult says it's actually clocking. And if I come up to A12, if I come to A13, we start to see it flash here. Hopefully the camera's picking that up, because it's half again as fast as the previous address. And we're definitely seeing, this is A14 and A15 will be the slowest. And again, it's just cranking away there. And we go A10 to A0 down this side. A10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then it should move to ground. Refresh is being clocked even though we're not using it. M1 is happening because the processor is running. Reset should be sitting as a high. Bus request should be high. Wait should be high. Bus acknowledge should be high. Write should be interesting. So write is being clocked and read is being clocked. So it's not necessarily an opcode FF, because it's trying to write. IRQ should be high. There should be no interrupts happening at this point. Memory request should be clocking, and it is. Halt should be high. Non-maskable interrupt should be high. Interrupt should be high. And we're actually seeing, that's interesting. So let's see, 1, 2, 3, 4, 5. That's data 0, or data 1. Data 0. Data 7, we're not seeing a signal. Data 2 we are. Plus 5. Data 6. Data 5. Data 3. Data 4. So why does data 7 appear to not be doing anything? It's just like it's open. Bad solder joint, maybe? Solder joints look okay. I did turn the power off here. Let's go to continuity mode here. And what I want to check is data 7. So let's see, 1, 2, 3, 4, 5. And then it goes data 107, data 1, data 0. So that should be data 7 there, if I can keep on it. And data 7. So they are connected. So it's interesting that data 7 didn't seem to be seeing a signal. Well, I think the next step is to get a pin header soldered in there. So we can actually force those to ground and go from there. So let's go ahead and do that. Power supply is turned off. I'm going to disconnect the supply completely from the system. We're just going to solder that in for the full length there. It's too bad the board's not silk screened underneath. Oh, you're kidding me. So it does go in there good. If it was silk screened underneath, I would put the pins poking out the bottom because it would make wire wrapping onto over here easier. Honestly, it's such a tight fit that it probably doesn't need to be soldered. So let's see, ground. That would be a ground right there. Ground wraps around on top to all of those. Yeah, let's go ahead and just apply solder. You'll see where I'm going here in a second. So let me get that pin basically in place so it doesn't fall out. Flip the board over. The header here is tight enough going in that it's not going to fall out while I solder. And of course, I'm working on an ESD surface that is grounded. The blue you see is an anti-static mat. The soldering pencil that I'm using, the tip is actually grounded on it, as it should be. So it's an ESD safe pencil. Although I'm not wearing an ESD wrist strap, my wrist over here is at this point in contact with the anti-static surface, or the static distributive surface. Say it right here. Other glasses, I'm looking for shorts between those. Don't see any solder bridges. We've got a ground right there. We're going to grab the wrap hardware here. And I am going to strip a fair amount off of this wrap wire, like several inches. And I'll show you why in a second. Assuming I can get it to strip that much. And we'll take the wrap tool. And I'm going to essentially use the long length of this to daisy chain the 8 data pins together. It's kind of a abuse of the tool. But it's one I'm going to do. So there's data 7. Just give it a couple of turns. Pick it up, jump to the next pin. The wire has wrapped around the wrap tool. That's not what I wanted. Give it a couple of turns. Pick it up to the next pin. Again, this is not recommended for long term. But for what we're trying to do here, this will be absolutely up towards ground. And like I said, the idea here was just to get those grounded. And this should take care of that. which will then force no ops onto the bus. Like I say, I have no idea what op code, if any, FF is. Wow, how did I get that so short? Well, doesn't matter. This is very temporary. I obviously didn't measure that well. Still, it's good enough. Continuity mode. Get on the ground. Yep, they're all grounded. It's not the most elegant thing I have ever done, but for the short term here, it's perfectly fine. So what that should get me now is the Z80 hopefully is going to be executing no ops, all zeros. Each time it reads, I should not be seeing write activity because no ops don't write to memory. The writes kind of confused me before, and I guess it means whatever the opcode was that was FF. So write should no longer being toggled, and it's not, but it should be reading. Perfect. Okay. Why am I not seeing any activity? That's really curious. Reset is high. Maybe it needs me to... That was it. I needed to do a manual reset, so the system didn't come up clean and reset the processor correctly, and that's why nothing was running there. And I actually know that's how this thing works. I just forgot. Come on, get off there. So now we can go through these address pins again. So back again, we shouldn't see write doing anything. It should be reading. There should now be activity. So there's A11. A12 should be slower. A13 slower. A14 we start to see the LED blinking. A15, that's the system clock, and the data pin should all be ground. And now we come over to A10. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So to me that looks like everything's working fine there. That is reading as it should. It's cycling through everything. So what we should be seeing now is the memory decoder, which is on this socket down here, should be firing on every one of the pins because we're cycling through all the possible addresses. That one's not doing anything. So let's look at the schematic and figure out what that pin that it wasn't doing anything is. So I thought all 8 of those decoded to something, but I could be wrong. Schematic's a lot to take in and keep in your head. So let's see. This here is the socket in question. That socket simply is there. Right now, pin 1 is hooked to pin 16. 1 to 16, 2 to 15, 3 to 14. 1, 2, 3, 4, 5, 6, 7, 8. And let's see, let's go to pin. So let's see, pin 8 is the ROM select. Pin 7 would be PROM 1 select. Pin 6 would be PROM 2 select. Pin 5 would be, so that's funny that there's no signal there. Pin 4 would be RAM select, so it is trying to talk to RAM. And there's 3 more of these MSC selects, 5, 6, and 7. So why is the one on pin 5 not acting completely open? Oh, interesting. It's got a signal on this side. It doesn't on that side. Bad solder joint. Power off. Continuity. Power is off. We should see these jumpered. So the question is, why aren't these 2 jumpered? They should be. That didn't help, dropping the board. It would be these 2 right here. I got a bad plate through, maybe? It really isn't connected. So what I'm seeing differs slightly from the schematic and the board layout. I'm not sure why that would be. But we are generating all of the selects, which is a good thing. So I can turn the power back onto the board. Let's go to the ROM socket and pin 20. Leads just love to tangle. So 13, let's see, 24, 23, 22. Actually, get this up where we can see it. 24, 23, 22, 21, 20. Huh? Oh, did one of the 24, 23, 22, 21, 20. So the chip enable is coming to the ROM. Let's look at the RAMs. Chip select is on pin 13 for the RAMs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. 13. 13, 13, 13. So we are seeing chip selects coming to the RAMs. U48 pin. Where's that signal driven from? So there's an enable for this guy down here that should be putting the data onto the bus when we do a read, and actually shouldn't be doing anything at the moment. We've got a mux up here. U47. There's 74 LS 138. Let's look at pins 1, 2, 3. We should be seeing activity. One, 2, 3, 4 and 5. Yep. 6. Then it goes 7, 9. 7's an output. 9's an output. 10's an output. 11's an output. 13, 14, 15, and we'll find +5. That's part of the decoding logic, it looks like. Here's what I'm looking for. U39 pin 3. U39 pin 3 is memory read, and it's happening. And U46 pin 6. That doesn't make sense. That's not. Okay, that is correct. Pin 6 is where it finally gets gated up onto. So that's happening. Let's go back to U39. Pin 6 should be sitting high. We're not trying to do any kind of I/O. Pin 11, 8, 9, let's see, 14, 13, 12, 11 should be sitting high. And 8 should be sitting high. And it is, and that's because we're not trying to do any kind of I/O read write or memory write. So all of that looks to be acting normally. Let's go back to the PROM socket. And pin 1, 2, 3, 4, 5, 6 should have activity. 4, 5, 6. I'm confused here at the moment. So let's see. 24, 23 should have activity. It's an address pin. 22 should have activity. 21 is programmer read. I wonder if that needs to be. Okay, read, the read switch would switch that to +5. That's the way I interpret this. Oh, it's tied directly to +5. Okay. And then we go on to 20, which is an enable. Then 19 is A10. And then we looked at A0 to A5 on the other side. So all of the addresses are getting to the proms. Oh, pin 8. So pin 8. Pin 8 is an address. Pin 1, 2, 4, 5, 6, 7. 1, 2, I don't know what 3 is. 4, 5, 6, 7. 1, 2, 3 might be power. 4, 5, 6, 7. And then 14, 15, 16. 14, 15, 16 all have address data coming to them on both ends. Well, everything I see there tends to say to me the system has enough in place to run. So it's possible there's an issue with the LED driver circuitry, which is why we're not seeing displays. even if the system's trying to run, although if I did a cassette load, I would have expected the load LED to come on. Well, I think that's enough troubleshooting for this video. I'm going to go study the schematics a bit more, and we'll come back.